Welcome everyone to this National Ecosystem Services Partnership webinar. We are doing the kind of usual approach. We are going to give a few announcements, then introduce our speaker, and do want folks to feel free to put questions into the chat during the discussion, and then we can use those for discussion at the end. And we also can unmute folks and do a little discussion one-on-one in the final part of the presentation. So, keep track of your questions. The discussion is great. We love doing that part. I also am suggesting you guys keep your lines muted so we can reduce any background noise. All right, anything else, Sarah, before we get started? All right, great. So today our speaker is going to be Justin Johnson. And he's going to speak about the global Earth economy modeling he's been doing. And we'll get to that in just a moment. So first, I just wanted to note a couple updates. We have a new journal article that recently came out that's led by J.B. Rule and Jim Salzman, really trying to figure out how we connect ecosystem service science and policy, and kind of comes up with a framework for how to think about that. And there are definitely some areas in policy where we've done a fair amount of science, but there are some significant gaps where science could inform policy that hasn't received a lot of attention yet. So this paper kind of walks through that. And there's the link to it. It's also on the Nicholas Institute and NESP websites if you're looking for it. Also wanted to note an announcement that I saw recently that I think would be of interest to this community. There's a new ecosystem services value database, and there is a launch event on October 14th that folks may be interested in participating in. And finally, just want to remind people that we record all of these webinars and they're available on our website. We recently had some great talks. We had one on payments for forest-based ecosystem services from private lands from Greg Frey of the Forest Service. And Bonnie Keeler gave a great talk about different methods and different values. And then we had a series of talks on equity and ecosystem services before that. And those are the kind of more recent talks, and those are all available online. And we hope you will partake and share those with others. All right. Now I'd like to introduce Justin. He's an assistant professor of applied economics at the University of Minnesota, and has been working with the Natural Capital Project. And his research really focuses very large scale about how the economy affects the environment and vice versa. So linking ecosystem services and large economic models. And I saw some of his work presented with another group and thought it was fascinating and would be a great presentation for this community. So we invited Justin to present, and I'm going to turn it over to him.
Great. Thank you so much for that introduction. Let me see if I can get the right screen shared. Are you seeing my full screen? Excellent. Well, thank you so much, Lydia and Sarah, for setting this up. I'm excited to talk. Like I said before, or as Lydia just said, this was a brief presentation before, but now I get a chance to describe a little bit more about this recent work we've been doing under the moniker Global Earth Economy Modeling. And I want to reference all my wonderful co-authors here, just a selection of whom I saw Erwin on the call, Juris Baldos, Tom Hurdle, Steve Pulaski, many others, too many to list here. But I just want to say that I'm going to be discussing work that's come from a variety of these people. So thank you to them. In particular, I want to start with the question of what is global Earth economy modeling, but also the supporting question of why should we even link economic models with ecosystem service models? What can we learn? But then I'll dive into an overview of the methods and the specific research advances we had to figure out to make this avenue be worthwhile. Then I'll talk about results from 3 questions that I think are important. And then I'll end with a brief discussion of frontiers. Hopefully then we'll have time at the end for a good discussion, maybe particularly on those frontiers. But just the context here for a second. Many here obviously will agree with this. Yes, we are currently flying blind, is how I would express it, into the Anthropocene. Or in other words, we have no adequate navigational system to help us guide our way to sustainable development. We know this is a problem because there exist planetary boundaries that we absolutely don't want to cross. But the past provides perspective, I would argue, for being in this type of situation. We faced huge challenges before, like for instance, the Great Depression, and specifically economics, my discipline, built tools to help us navigate out of that depression. And two specific ones I reference here are the systems of national accounts, SNAs. These are responsible for calculating GDP. As well as the economic models, such as computable general equilibrium, CGE models that I'll be talking about throughout. But maybe even just more fundamentally, those models are things that you might know, like supply and demand. These are navigational tools that help us build back from the depression. And so something that I say that's sometimes controversial and not everybody agrees with is there's great value, I would argue, and a great success that came from economics. We did phenomenally well at improving physical consumption and the well-being that comes from that. This can be seen as huge poverty reductions in the US and worldwide. But success here directly leads to new challenges. And so rather than the underconsumption of the depression, we now face problems of overconsumption. And this has really made evident that we have, here in economics at least, we have a massive blind spot. And that's the economy is embedded in the biosphere. Simplifications may have been useful enough to get us out of the depression to ignore some of these things, but as we face problems of overconsumption, this embedded nature is absolutely critical. And I think this is evidenced well lately by COVID, as that challenges are global, the solutions are interconnected, and a common theme through a lot of these are there are common resources, common pool resources that we have to manage well at a global scale. Now, economists already do global modeling, you might surmise. And in fact, they are enamored of global modeling, and it goes under the moniker general equilibrium analysis. And this is what I had to learn in my PhD, as all economists do. What is this general equilibrium and what does it predict? And why am I saying it needs to be broadened? And basically what I'm going to argue here and throughout is that we need a more general equilibrium. And that's what I mean by needing to embed the general equilibrium, which seeks to define the whole economy in a context that defines everything outside of the economy that can be used as inputs or have interconnections with the economy. And so I think, on this point, there's a growing consensus that sustainability requires considering the entire bioeconomic system. In the past, most of this analysis has looked at how does the economy affect the biosphere through human impact on things like land use change. But I'm also going to argue here is that for this full consideration, we also need to consider how then does the biosphere affect the economy. And this group, I think, will be well inclined to see ecosystem services as an important thing, such as providing clean water. But this is a very general statement. What I want to actually discuss is that we created a new specific model, GTAP-InVEST, that I'll talk about, that enables this type of analysis by linking a very frequently used economic model, GTAP, with InVEST, which is a set of ecosystem service models. The reason I want to do this and present these tools is because I think it gives us insight on the three big important questions for sustainability science that we just need to answer. The first one is how much does nature benefit the economy? And in particular, I'm going to aim for talking about this and how it must be in measurable terms if we want to influence decisions, while also accounting for whole economy general equilibrium impacts. The second question I'll answer and give results for is who loses or wins when nature is depleted. Fairness is incredibly important, and we must consider how economic activity may hurt people, or rather that conservation may limit economic activity and hurt specific people if it's not designed well. And the last question I'll talk about is how then can policy protect nature's value and do this in an equitable way? Or in other words, what can we do? To get us there, though, I do want to talk about the specific methods that made this advance happen. I mean, maybe this could also be seen as, why hasn't this been done more? And I think the answer comes down to is it's challenging, but we're in a unique spot where we're making progress on some of these three specific points. And so the first one is sort of straightforward, and I've already talked about it, but we needed to actually link two big and somewhat dissimilar models, GTAP and InVEST. And so diving into those two models first, before I talk about the linkage, is GTAP is the Global Trade Analysis Project based out of Purdue University, founded a long time ago by one of our team members, Thomas Fertl. And it's grown to be, in some senses, sort of the common language that is used on trade questions. Like, for instance, if you're going to analyze Brexit or a trade war with China, this is exactly the sort of model that will get used and is just understood by ministers of finance and many very important people. You can see it's got some pretty prestigious organizations that are behind using it. They provide two distinct components. One is a database of all the values that are necessary to do the sort of economic analysis that it's known for. But the second, maybe less known, is that it also has a core model, a computable general equilibrium, or CGE model, that works extremely well with this database and can answer questions. So with the fear of oversimplifying compared to some of the experts that I've seen logged onto this call, I just want to take a step back, though, and answer what is a CGE. And so a CGE acronym here, the first one is computable. This is a type of modeling that is laser focused on policy analysis. So thus, it must be sufficiently detailed, meaning having enough sectors or regions or inputs to do real world policy analysis on important questions. And related to this is it's got to be linked then to real world data, so systems of national accounts. And the computable part of it means it must be computable in finite time. And so not just a theoretical model, but one that you actually can find a solution that is going to arise from all the complexity that you've added. But general, then, I've hinted at this before, it's general as we're saying that all parts of the economy interact and everything is included. So in other words, subsidizing wheat production in one country is, in principle, can, though the effects might be very small, affect automobile production, for instance, in some other country. And this happens by changing prices, changing usage of inputs, and as well as trade linking all of our regions. And then finally, equilibrium hints at the nature of how we find a solution here, is that we're going to assume basic economics 101 is that producers maximize profit, consumers maximize utility, and prices adjust until we're in an equilibrium where supply equals demand. But because we're in this context of computable general equilibrium, this relatively simple framing is actually, as you might guess, far, far more detailed when it starts to hit the complexities of the real world and the data that we have. And so just to give a flavor of that, within each region, we're going to have households maximizing utility based on extremely detailed information about expenditures, taxes, savings, et cetera. And on the other side, we have producers maximizing their profits using different combinations of inputs, labor, intermediate goods, and, as I will argue throughout, really critically, land. And I mentioned land because this will be one of the key advances we have to address. How do we get land into this equation in a very useful way? But to note, I think, is that within the GTAP world, there's lots of detail. So production is going to be expressed with considerable detail. And so just using the land example again, we have land allocated optimally among different nested production choices. And these are going to be defined for specific agroecological zones in the version of the model that we use. And so I just want to say throughout, this is not some sort of theoretical model of economics, but rather something that is aimed at having the real world complexity we need. The second model is that of InVEST, the integrated valuation of ecosystem services and trade-offs model from the Natural Capital Project, where I worked for 5 years before starting the new position in applied economics. And the Natural Capital Project is a partnership of WWF, the Nature Conservancy, Stanford University, University of Minnesota, Chinese Academy of Sciences, and I have an outdated slide here. There's also the Stockholm Resilience Center. And perhaps the thing NatCap is most known for is InVEST. It's an open source software tool that estimates 20 plus ecosystem services using spatially explicit, high resolution, process-based production functions. And recently, I would say, is that this is done at a global extent. So some of the stuff I'm going to talk about is really newly possible. I'd reference, Chaplin Kramer et al. 2019 in Science, where we talked about how we're now able to calculate high resolution global ecosystem services, such as this map here. And this really is the enabling fact, this capacity that enabled all of the work then that I'm going to talk about with GTAP-InVEST. If we're going to link to a global CGE, we obviously are going to need global ecosystem services. And so currently, we are including 5 ecosystem services: pollination, coastal protection, water yield, carbon storage, and marine fisheries. And the main task of this first research advance of actually making the linkage is thinking about how do changes in each of these services lead to something in the GTAP model that changes. And so this is, to use the example of pollination, what that is going to mean is where there is a reduction in wild pollinator habitat, there will be less productivity of crops that are pollinator dependent if they are within the flight range, literally, of the pollinators flying to and from their habitat to the crops that they might be pollinating. And so I don't have time to go into all the details or even the spatial results, but basically that was one of the key lifts in this, is calculating all these at the spatial extent, which oftentimes looking at these maps is not very useful. And so just keep in mind that we always have very detailed representations. So this whole model is running at 300-meter resolution, where we can analyze then how does ecosystem service provision differ under these different scenarios. But we did that for pollination, carbon storage, marine fisheries, coastal protection, and water yield. So that could be a whole talk, is how did we did that. But instead, I want to talk about how did we use this in the broader context of GTAP-InVEST to answer questions of where does the economy affect the provision of these ecosystem services, and then vice versa. How does a change in ecosystem services filter back to impacts on the economy? The basic model linkage that we used follows this sort of simplified approach. Is we have glued together all these models, where we first run GTAP and a specific version of GTAP called GTAP-AEZ, where it includes details on agroecological zones. We run that once out to some sort of future year like 2030 to get economic projections of a business as usual scenario for that we want to compare against. And also it's worth noting that this is a heavily modified version of it, where we consider endogenous land use change. And so I'll mention that in a moment. Then the next model here is a very relatively new one. The SEALS model is necessary to downscale results that come out of our GTAP run 1, which is happening at a 340 or so different global regions, to a scale that is able to be used in ecosystem service models. And so we downscale regional changes in land use to a 300-meter resolution that is the sort of the coarsest, but still suitable resolution we run in InVEST then. And so the SEALS model is just the way that we do this downscaling. And we'll talk more about that in a second. And then finally, once we have those high resolution land use land cover maps, that's the input to InVEST, where we then run each of our different models and see then how will that affect the economy by shocking the system, if you will. What happens when that changed productivity from pollinators is lower, or what happens if there is less timber provision, for instance, given the landscape that we have. And so the second run of GTAP then calculates the impact of changed ecosystem services on economic performance. Okay, so that second research advance then, diving in just for a second, is that connection of global, local, global interactions. And at a practical level, this means getting really good at translating from regional level observations with regions to grid cells. And that's really been the missing link for a long time, is the step of downscaling. And so we created this model just starting to get documented in the literature, but basically it can take anything that's a coarse resolution of change. And so for here, I have the course is a gridded representation of land use change from the land use harmonization project, and then put it on some sort of higher resolution representation of where there's grassland expansion, cropland expansion, et cetera. And the key advances there, which I won't dig into, is that this is empirically calibrated with a time series of data and can incorporate grid cell level interventions, like installing riparian buffers, for instance. This is something that happens at a very hyperlocal scale, and this allows for that. The outputs then, zooming in, is going to be a global wall-to-wall coverage map of different scenarios that reflect both the change in how much land use change we have projected by the GTAP results, but then also where exactly does it go, along with what does it look like to have different policies implemented. And so for here, we didn't do riparian buffers in this analysis. Why can I not? There you go. Is that it identifies where's the crop expansion versus where is that riparian vegetation. And why is this important though? Why do we need such high resolution? And I would argue that it's because there are some phenomena where the specific location of where the activity happens has a really large effect. And so an example in a recent paper that we did is looking at this, and this image is showing where is there agricultural expansion. That's the purple grid cells. And then in the background, if you look closely, is where is there carbon storage. And what we interestingly found is that the location of where those purple grid cells happened within the sort of coarser resolution of change mattered more for how much carbon storage is lost, simply because it can avoid the forest, than the sort of coarser representation of where throughout the country should the agricultural expansion happen. Then the third research task was endogenizing the land use change component. So background here is land within the GTAP standard model Landis is represented only in monetary terms in the core model, but we're using this GTAP AEZ model, and this has the advantage of representing land as hectares, which is a useful truth, rather than just as dollars, but it was still assumed to be a fixed stock. And so our advance was to allow for the endogenous expansion of economic activity. So for instance, if production on land becomes more profitable, we would want this to be able to lead to more land being brought into production. So the basic economics 101 approach there. The way we did this is for each region within our GTAP model, we calculated the total land available to the economy and identified what is the shape of the curve, whereas you have natural land area converted, what is the land rental rate that you would pay to have that. This was calibrated based on the shape, but also looking at what is the total land available. And so the intuition here is that as you use up more and more of the land, convert the natural land, the price is going to go up. And this would be, thus, this ties it to connections of production, is that if the profitability of production goes up, higher and higher prices for land would be paid to increase production. But because everything we do here is at a spatially explicit level, we actually calculate the shape of these curves by the same high resolution suitability data and define the shape of these curves in a way that's unique for each agrological zone. So there's a lot of realism here. But what it's useful for is that it lets us calculate things like what is the opportunity cost of protecting land. And this is something that's often not measured in the conservation community or even just considered, is that protecting land is, in some cases, not always, but sometimes, removing it from economic use, and this can have costs. And so this can be represented in this model then by a shift in this land supply curve. We'd see the asymptote shift left because we've taken land out of being available for the economy. And what this does is it leads to the price that people are willing to pay for land to go up. So there's a new land rental rate, as well as less land being used. And so the critical methodological point here is that this means removing land from production is not free. It might well be, and we argue is very often absolutely worth it, but we need to consider, especially from an equity lens, what are the costs of doing so? Okay, so now I'm going to shift gears to results briefly, and I'm going to present my results in these in 3 questions. And the first question then is, how much does nature benefit the economy? And this also is a bit of a historical dive. It talks about the first engagement we had on this topic was with the World Wildlife Fund for their Global Futures Report. And they wanted to know, what is the impact of nature on the economy, sort of towards like a big numbers type of questions. How valuable is nature? Now, of course, that's nearly impossible to answer, but we wanted to add a little bit more specificity on what could we say in terms of how the economy affects, is affected by the environment. And so we put out a couple of papers where essentially what we did is compared two scenarios: a business as usual, which has, as you'd expect, energy intensive consumption and continuing land use change, as well as greenhouse gas emissions that continue to rise. And we compared this with a global conservation scenario that has different assumptions on consumption, like being at a more sustainable rate and also stabilization of land use change. So this is actually where those pollination figures that I showed before came from, is we calculated what is the amount of impact on the economy as measured by the difference in GDP, which is a flawed metric, but is still persuasive. What's the difference in GDP between these two different scenarios? And that's at least some useful information about how valuable is nature. And our key finding is sort of the one that we all knew in advance, and that is the one that WWF was happy to see, but is that we found that nature does indeed matter quite a bit when expressed in these terms. And so that means following the global conservation scenario, avoided about 10 trillion in losses by 2050 compared to business as usual, in terms of losses that not protecting ecosystem services would have inflicted on the economy. The second, less expected result is that we found that investing in ecosystem services is most beneficial to low-income countries. And so that can be evidenced here by, under the business as usual, we see that this red bar, which is the percentage change in GDP when you include ecosystem service damages, most of the losses are concentrated in business as usual in low-income countries. And so I guess the point here is that low-income countries are most affected by lost ecosystem services. But then simultaneously, following this other global conservation scenario, we see that the increase from this point to this point is the biggest percentage change also. So in other words, doing smart policy towards protecting ecosystem services also stands to benefit the most in low-income countries. That teed up then a new engagement that will be the second question I want to address, is who loses or wins when nature is depleted? And this came up because simultaneous to this project, a very landmark report now that is published, The Economics of Biodiversity, also known as the Dasgupta Review, made a very strong case that nature is especially critical to low-income individuals. And they saw some preliminary results, and so commissioned us to assess this, in particular under the content of what happens when tipping points are passed. And so that was a wild success, and we got buried in box 14.3 way back in the end. No, but I was very happy to be included in this, because this was some results that I think were making this very important point, is that ecosystem services are important to the poorest countries the most. And so here just illustrates that, as well is the new results that we generated for the Dasgupta Review found the same thing, is that on a year-by-year basis, there's 2.7 trillion in losses from hurt ecosystem services. But as a percentage of 2030 real GDP, under this collapse scenario, we saw that it was approximately 10% of low-income countries, but much, much smaller for every high-income group, as little as 1% for the high-income groups. On a side note, these sort of big numbers that we're putting forth, these are extremely conservative estimates for all sorts of reasons. Number one, they don't include climate change impacts. That wasn't what we set out to do. But also, we're only measuring the ecosystem services that we have enough understanding to make this linkage to the economy. And so we've excluded a whole bunch of ecosystem services. And thus, this is an extremely conservative estimate of losses. But then question 3 is more to the heart of what I'm interested in, is how can policy protect nature's value and equity? And here is the most recent project that we've been working on, is an engagement with the World Bank, where we assessed how specific policies could mitigate losses from ecosystem services. Or in other words, on the heels of that Global Futures report, we wanted to answer, the World Bank wanted to answer questions not just of what is the cost to nature, but what can we do about it? The global conservation scenario that we defined for WWF wasn't specific about what are the policies, like is it a tax, a subsidy, a trade adjustment? And so we convened some in-depth discussions with the World Bank to identify what policies, at least from their perspective, would be interesting to assess that might improve outcomes for both the economy and nature. And so we identified some basic policy options, which are two versions of a payments for ecosystem service scheme, a local one where each country is responsible for their own scheme, and a global one where we actually allow transfers among countries to have, for instance, developed countries provide large payments to tropical, especially countries, to pay for protecting their very valuable ecosystem services. We also considered what in the World Bank lingo was decoupled support to farmers. This basically means removing agricultural subsidies on the idea that subsidizing agricultural production may make us expand into natural areas more than we would want to if we didn't pay them to. And then finally, we considered what about research and development? Could we have gains to the environment by having research and development leading to higher yields and thereby potentially less agricultural expansion? And so we then combined these in different policy options and layered them on in different ways. That's not interesting, but we dubbed these nature smart policies. But one that I want to talk about specifically is we really got to do some fun design of these policies. We went in quite a bit of depth then on the payments for ecosystem services scheme. So just a very quick rundown of where we went there is from an in-review manuscript. We calculated at this same global high resolution approach what payments would be optimal to offer landowners, at least in this case, given perfect information on their on the conservation value of their grid cell, as well as the opportunity cost. And so this identifies specific payments to be made, and also identifies what would the total cost necessary be to transfer from one country to another to get these payments funded and make that happen. But long story short, this is then the output of this policy analysis. We plugged our different policies into GTAP-InVEST, and we can see them plotted in many, many ways. This one plots them as on two axes of talking about how much does following those policies result in avoided natural land conversion on the horizontal axis here, and also then on the change in real GDP relative to business as usual on the vertical axis. And so the left plot here is our three policy things in isolation, excluding R&D for the moment. And then we combine those up and we see, we'll link back up and say, the first thing to notice is that all three of these policies are positive both for the environment, at least on this metric, and are good for the economy. This was sort of by design, but this is what we were hoping to find. Then not too surprisingly is in combination, they outperform. And then especially when you add on research and development, they greatly outperform. And so the best policy combination was all of the policies, this one here, that had the most avoided natural land conversion, as well as the most increase in GDP relative to business as usual. So diving into those research and development results, again, we found the same key message that protecting ecosystem services is critical to developing countries. And especially research and development. And so what we have here is our policies with the impact, the benefit of the policies split between low and middle income countries versus high income countries. And you can see here the same things, that the benefit is the most to low income countries. But then as soon as we add research and development, we have this huge jump upwards in value, of course, but also this increase is largest for these same low income countries. And so that's been I think, really important finding that's been really exciting to work on coming forward. And because I think I have time, yeah, I do, I'll include my bonus policy, which was, could we use this model to assess other types of things that were outside of the domain of what the World Bank wanted to assess, but we analyzed the question of how much would it cost to achieve a really ambitious land protection goal. So there's many goals out there. We looked at achieving 30% protection of natural land by 2030, including the costs. And our model was positioned well to assess this because we had done this endogenous land use change. The basic finding is that protecting 30% of Earth poses conflicts with agriculture. To give you a hint of how we did this is we identified a composite conservation score. I won't get into the details, but basically something that is a weighted average of ecosystem services. And our idea of which grid cells to protect was based on, well, let's just protect the highest conservation scores one. This is sort of a naive simplification, but it was enough for us to ask then, where would that conservation have conflict with agriculture, which is plotted in the orange down here. And so by identifying both the optimal locations to protect and the areas where this protection would remove land from cultivation, we could model the endogenous effect by saying, okay, let's shift our land supply curves that I showed before to the left. And this, as we also discussed, will drive up the prices for land. This will have real impacts on GDP, but also things like consumer welfare, which is one of the outputs of our model. And so the last thing I want to discuss then is just one specific research frontier that has really emerged as important, and perhaps our discussions could talk about this given the focus of this group, is national level analysis of this. GTAP is the global trade analysis project model, and so much of our analysis was at the global scale. But many of the policies we might want to consider are going to be very much more local, or local is a silly word there, at a national scale, but we need more detail for specific countries. And so we're exploring opportunities to create a US specific version of GTAP-InVEST, which would, number one, mean running ecosystem services for the whole US on the NLCD. This is currently possible for a wide variety of ecosystem services, but we still need to get it done. Many others here have already done that. But being able to have that done quickly and then inputted into our economic model is what we aim to do. Another advance this would require then is doing land use change modeling projected using the much higher quality US time series of data from the National Land Cover Database data set. And then also, while we're here, we might as well think about explicit linkage to SEA, or the System of Environmental Economic Accounts, and report natural capital accounting figures. I think this is also emerged as something that we want to do more of. There's great interest from the natural capital accounting community, and just projecting how would those change in a time, especially when we consider the whole economy impacts. And, this is kind of fun because we get to move away from the global data, which are great but limited, and look at training the SEALS model, for instance, using much better US data. And I call it fun because you see sorts of aberrations that we don't see at the global scale. Like if you notice here, what does that look like? Maybe some of you can guess, but that's a NASCAR site. So land use change modeling, when you get more and more detailed, has to take into account ever more detailed phenomena like NASCAR racing in the parking lots they built in this particular location, which is in Kansas. So that's just a hint at some of the things that we want to talk about as potential next steps, basically going national, and not just for the US, we also want to engage on other ones. More ecosystem services is always a huge part of where we want to go, so as to address this fact that we're only estimating a very small conservative subset of ecosystem services. But then ultimately, I think the long game is think about how can these results be used by the World Bank or by others in some of the key international negotiations coming up, such as the COP or the CBD, that have been delayed due to coronavirus, which is good for us here because it means we can hopefully then still inform some of those negotiations. And so I think I have succeeded at leaving quite a bit of time, 20 minutes, that's great, for questions and discussions. But just before we dive into that, I want to shout out, feel free to contact me. I know I went through a lot of research real quick because there's many teams involved here, but I'd be happy to talk more details about any one of these. And with that, I would like to hand it over to the discussion section of this, which I believe Sarah is going to be selecting questions and going from there. And I think we're requesting people put additional questions in chat. Is that right, Sarah?
That is correct. Yeah. If you have any questions, just type them in the chat and I will try to get to as many as possible. So just to start out, somebody asked, Can the model be applied having a starting unit of the analysis of a portfolio of companies?
That's a great question. I say it's a good question because if I were to include one more sort of future research direction that we would mention as coming up a lot, it is in this connection of how can we link to finance decisions? Can we create metrics for sustainable investing? It's challenging is the short answer, insofar as this is a global trade model and it doesn't take the detailed firms as its unit of analysis. It instead uses sectors of the economy, but there's a little bit of crosswalking you can do between them. So we're exploring with a number of partners, how could we actually think about a corporation's specific change? And the one we've gotten the most progress on is thinking about what if corporations in the tropical palm oil production sector were to do wide-scale implementation of certification standards. What impact would this have on the economy? So some of these questions are already possible to be assessed, but the bigger answer really is there's a lot of work still to do, but it's exciting. We just need to figure out how to have more detail about specific firms or corporations in the model.
Yeah, I'm sure you'd have a lot of interest there. This is a relatively easy one, but somebody asked, how did you select the ecosystem services that you included in the initial GTAP-InVEST?
That was totally self-serving in the sense that it was the full set of ecosystem services that we could actually calculate globally, as well as the ones for which we felt that the literature was strong enough to make a connection between how does the change in the ecosystem service filter into effects on the economy. So in some senses, we're looking under the street lamp. We're only seeing things that we are able to calculate and are close to what we already do. And so this is an admitted bias, but this is also part of the research agenda of where we can go next to start to be more systematic about which ecosystem services need to be included.
Yeah. Have you had particular interest in adding in specific other services?
The biggest one, the two biggest ones are sediment retention and its effect on degraded yield to agriculture through erosion, as well as the impact on the economy through reservoirs getting sedimented and having less productivity for hydropower production. And the second one is through tourism, ecotourism. How is that affected by changes in natural environmental capital that is critical for that?
Hmm. Well, we'll be waiting with bated breath to see those. Okay, I have another question that came in. Someone asks, wouldn't it be that the amount of ecosystem services in developed nations is rather low as compared to low-income nations? A point argument for this is how high-income nations are outsourcing most of their diets, causing elsewhere or impacts elsewhere to ecosystem services. I think this one came in relation to your results for question 2.
Yeah, no, I mean, first off, I'd agree with that, is that a lot of that result is being driven by the fact that ecosystem services in developed nations is rather low. And part of this is because, well, we've already depleted a lot of our natural capital. You kind of hint at key equity questions too, is that, well, now we're outsourcing our impact. This can be analyzed through things like embedded biodiversity loss in trade. But that's definitely the case, is that high income nations are outsourcing their damages. But I guess the argument that I was putting forth there is that developing countries still have, at least by this analysis, more of their natural capital and ecosystem service value available to be protected. A lot of that's driven by the fact that they just haven't yet diminished them in the way that developing countries have. So totally agreed, but that still means there's a real opportunity to figure out what are the policies that simultaneously address development needs, increasing food security, et cetera, that are economic and production questions, while also trying to think about, can we do this in a way that doesn't deplete this stock of natural capital in these countries?
Great, thank you. All right. Another one from the chat is, this model is implying a perpetual non-finite form of economic growth, bringing it up by 2.5 times what we have so far, with no expansion of land for agriculture. So I think first I want to see if that is correct. And then second, if that is correct, what are the output efficiencies assumed by agricultural land to compensate for the shift of displaced land?
Yeah, thank you for the question. I mean, first, just a clarification. We do allow for expansion of land for agriculture. More specifically, we model, and this is the whole endogenous land use change component, we model how would the expansion of agriculture, pasture land, and managed forests expand. And so this does allow for natural land being converted into these economic uses. But then the other part of the question, though, is still valid. Is what are the output efficiencies assumed here? Is that this is endogenous. Again, to say that is that the productivity is going to be a function of the inputs, and so how much land and capital you have, as well as the efficiency calibrated by the underlying input-output model, which is one of the key parts of GTAP. And I didn't have a chance to get into that, of course, but there's a great amount of research of what goes into calibrating those input-output relationships. But the note I'll leave you with is that by allowing agricultural land to expand into natural areas, we at least allow for this interplay between, is the food security problem going to be solved by just ever increasing yields, which sometimes is the way these sorts of analyses go, or is it going to be met by expanding? And so our model can see how these two alternate ways of producing play off against each other.
And you mentioned that right now the models don't incorporate climate change parameters, but have you thought about how you might incorporate climate change, like things like sea level rise or heat stress, into these models, which will ultimately have economic and ecological impacts?
For sure. That's outside of what we have currently focused on. We're really coming at it from the point of view of ecosystem services and what is their benefit to the economy. But that's just where we started looking. I mean, there's nothing that we could do that is broad enough in scope to answer some of the large sustainability challenges we have that doesn't include climate change directly. And one idea that we've been toying around with is what if we included directly some of the economic integrated assessment models on climate change, like William Nordhaus, Nobel Prize winner's DICE model. That would be almost ready to drop into this model, where the economic productivity of different sectors is plugged into these damage functions, to reference a very large literature, but then be able to think about the climate changes calculated fully within this model as well.
I needed to unmute. Someone here who is interested in assumptions and uncertainty, always a big area of interest for these types of things. So they say, I know there are many, but can you talk about one or two areas of assumptions and uncertainty and how they impact your results and what you can learn from them in terms of maybe sensitivity to assumptions, things like that? Yeah.
Well, first to note is this domain of global modeling, and especially this domain of linking global models at the macroeconomic trade level to hyperlocal ecosystem service models. This is really uncertain. I'm just going to acknowledge that straight up, is that this is very challenging to be accurate. And so there's a high degree of uncertainty and reliance on the assumptions. That said, that's why I started this discussion with the point of flying blind and how we need to work towards something. And so my contention would be is that although there is great uncertainty, models like these do allow us to sort of play around with different assumptions and see, at least in these models, which are the changes in assumptions that are particularly problematic, a warning system, if you will, about what sort of changes to avoid. But maybe another way of answering this question is that, what assumptions are there? You're interested in specific assumptions or uncertainty. And I'd say the single biggest one is that we are indeed assuming a standard economic model. I think, an alternate way of approaching this question would be to say, let's not use a standard utility maximization, profit maximization approach. Thinking about work that thinks about Kate Rayworth, for instance, donut economics, and thinking about how we need totally new systems. I think that's the big assumption that we make, is that the standard economic model is relevant here for these large system changes. But that said, there's also then, we could chart out specifically what are the underlying sources of uncertainty apart from those assumptions. And I think there probably the biggest one is either within the specific ecosystem service models, like what is the flight range of bees on a landscape. We had to simplify it down to be just a representative pollinator, but that means we're missing the complexity of what we do know about specific pollinators on specific landscapes. So that's a huge part of the uncertainty. And then another one is just obviously predicting land use change is almost impossible. And so great uncertainty comes in our assumption of downscaling the course level changes in agriculture, pasture, and managed forestry to specific grid cells. That's the second area of uncertainty that I think is most relevant.
Thank you. A lot of food for thought there. All right, I have a multi-part question, so I will ask it in parts to give you a little bit of a break here. So the first one is easy. What is the time step length of the model?
I'm so sorry to give a technical answer here, unfortunately. It's a comparative static model, which means we're comparing two different equilibria. And so the time step that implies then is we assume the policy happens in 2021, and then we model the effect of the policies out to 2030. But we're only analyzing the starting year and the end year. We don't currently include the time series. Partially, that's just from a computational feasibility point of view, but it's definitely something that we're looking at, is how can we calculate this in a more dynamic framework.
All right. The second part of this one is, do you have economic activity in GTAP associated with protected areas? And so they provide an example. In Montana, we find counties with high % protected lands attract more unrelated economic activity.
That's something we don't include. We have the very basic assumption that if land is protected, it can be characterized fully by how protected is it. So we do allow for partial protection of land, like a paper park or something like that, where there's not great enforcement of the protection. But I think what you're hinting at is that perhaps land can be both protected and have some economic use. We sort of simplify that down into a relationship of simply how protected is it, and if it's fully protected, it's just removed from being an input to production.
And then another sort of economic piece that they're interested in is, does your InVEST model include harvested wood product carbon storage?
Yes. Yeah, so that comes in the managed forestry sector. Logging forestry is a huge part of this. Although, let me clarify that. I think I answered too quickly. We did consider the effect on that sector, but we didn't explicitly calculate the carbon storage of those wood products. So sorry to be a little too quick on my answer there. The little research that I know on this, though, shows that's important but small compared to the sequestration change from the actual land use change rather than the net result of the product. But I'd be happy to get pointed to new resources on that.
And then someone asking about the results. What is the main explanation for economic growth in low income regions, economies with the higher conservation scenario? It seems like this linkage could be a key message to help push policy and enforcement funding.
Can I ask for a clarification on that, if possible, from the person to chat or speak it out? Which of the conservation scenarios are you referencing? Because it's a little different between them. Is this the 30 by 30 policy analysis or one of the other ones?
The first.
The first one. Okay. I'm just gonna pull that up actually. If I can find it. Too many slides. I'll just go off memory here. The answer there is that we're considering the effect that ecosystem services have on the economy, and so if you include changes in ecosystem services without any sort of policy towards protecting them, the inclusion of those ecosystem services is on net very negative for economic growth. So in other words, if compared to a business as usual, where we assume that ecosystem services don't matter, or at least are contributing the same amount, our business as usual found that including ecosystem service has services has the biggest impact on low-income countries. And it's really that leads to the results that the policies which seek to preserve ecosystem services have much less loss. And so it's not actually a gain in GDP, it's that most of the losses that they would have otherwise incurred by having their natural capital degraded can be avoided by these smart policies, whatever, that we identified. But to the point though, I mean, this is definitely one of the key things that I think can be talked up is that there's a lot of opportunity in these countries to do exactly that. And there's a large gain to be had.
And so I've reached, I think, the last question that is entered into the chat. And it's asking about the complexity of the agricultural processes included in the model. So GTAP has an agriculture focus. It goes down to crop types. Has SEAL also predicted the change of specific crops or other things like intensification or crop rotation, which might be even more complex?
No, I would definitely love to see it go there. Was that Youngger that asked that? Yeah. That's a great area to go. SEALs currently doesn't, it just simplifies it to agriculture, pasture, or forest, managed forest. But you are right to point out that GTAP has this more detailed agricultural information. And so that could absolutely be included. The challenge there, as I know you know very well, is that identifying the specific locations of different crops would be critical to this. And so connecting with some of your work particularly, I think that could be done to increase the detail so that the land use change component is actually expanding specific crops instead of just agricultural land. Yeah, that would be great. Oh, and I didn't really answer the other parts of the question. Intensification, rotation. Intensification is accounted for, at least insofar as intensification through increasing inputs, labor or capital, as well as intermediate products, but then also just the overall increase in technological efficiency, which can further be modified by research and developments. That part's included in the model, but we don't have anything about it, like rotation or crop rotation specifically.
I like how you knew exactly who asked that question, just by the question. Well, we are just about out of time and I'm not seeing any more questions coming in. So thank you all for your attention and for your great questions. I feel like we grilled you pretty good here, but that was a great discussion section and a great presentation. So thank you so much for being here today.
Well, great questions. And thanks so much for inviting me.
Thank you, Justin.
Bye, everyone.
Bye everybody.